So my name's Simon George. I'm a professor at Macquarie University in Sydney. So I'm a professor in organic geochemistry, which is an interesting discipline that you probably haven't heard about. It's something that's in the middle or between the axis of geology, biology and chemistry. So this field is an interesting one because it enables us to look at rocks and we look for biological information in those rocks and we use chemical techniques for doing so. So the things we're actually looking for are called chemical fossils or biomarkers. Certainly I consider myself to be an astrobiologist. Partly that's because I teach astrobiology. I have a big class who elect to do it at Macquarie University. I often have more than 200 students every year doing it. But also my research group and my research interests include things that are really astrobiology, partly about early life on Earth. So what we can do with these geochemical techniques is actually understand rocks that are between 1 and 3 billion years old, and we can look for chemical evidence of the things that were living on Earth at that time. And at that time, Earth was a very different place, and in fact it was probably more similar to Mars at that time. So there are similarities between Mars and Earth which we can make use of. And what we're interested in doing is seeing what is the evidence for the development of life. What sort of things were alive on Earth, say 2.7 billion years ago, before the Earth's atmosphere had any oxygen in it. We know there were bacteria and archaea, but some of the information that we have say there were more complicated organisms, which we call eukaryotes, which are the ancestors of us, ancestors of animal and plant life. So my parents were strong scientists, and on family holidays we often used to go around picking up bits of rock from ore deposits and understanding how marshes were growing and the reeds in the marshes and the birds and everything. So I was always exposed to science. But interestingly, my careers advisors said, although you have interest in science, you're no good at it. At school I was hopeless at science. But it shows that if you persist in something that you really love, you can actually grow to be better at it and maybe even a professor at a university in it. So I was able, very luckily, to do geology at school, and I went then to do a geology degree at St Andrews University in Scotland, and then went from there to do a PhD in organic geochemistry. In the meantime, having worked on oil rigs to get a bit of money. So when I first came to Australia, I was doing research science for the point of view of the petroleum industry, and I worked for CSIRO for 15 years. But during that time I got more and more interested in looking at really old rocks, and that drew me slowly into astrobiology and eventually drew me away from CSIRO and into the university environment. So the great thing about Macquarie University is it offers these general science units which all students who come to Macquarie have to do at least one science type unit. We call them planet units. So my unit, which we call Life, the Universe and Everything, is one of those units. And I draw students from accountancy, from humanities, from commerce, from marketing, as well as from the Faculty of Science. So I get a very wide range of scientists coming to learn a little bit. And they only probably do one unit of science in their whole time at university. And if they come and learn a bit about astrobiology, I think it's a tremendous thing because it's a very interesting subject that can involve all sorts of different parts of science and draws it together into some really important question to answer. But I think it's quite possible that there was life early on in Mars, say 3 billion years ago. If it's still there on Mars, it is not on the surface, so I think it would be below the surface. But I think if we drilled a drill hole a few hundred meters into the surface of Mars, we might find a warm water aquifer with maybe surprising result, maybe some bacterial, archaeal, microbial matter still living down there. To me, it wouldn't be very surprising. It probably would be very surprising to many people in the world, knowing that there's a second genesis of life. But to me, not very surprising as a scientist.